Hello, and welcome to this talk, which is on open source AI chatbots. I added the open source because I realized from the title it wasn't super clear where the open source part came into it. So today I'm going to cover three things. So the first one is what do I mean? Because if you are working in the field of machine learning or data science, you probably know that AI is a little semantically bleached, I think is how I would refer to it. And then we're going to talk about how they work, some of the approaches that we take at Rasa with our framework. And then finally, what does the development process look like? Because this is a very different way of developing chatbots if previously you've mainly been working with rule-based state machines. So open source AI chatbots. This is a little bit less of a mouthful than how I would describe it a little bit more exactly, which is that Rasa is an open source framework for building task-oriented dialogue systems using both machine learning and rule-based methods. And I'm going to break down all of those a little bit more. So first off, open source. Yes, we are open source. So we're licensed under Apache 2.0, and I'll have the GitHub link in the final slide, or you can just search the Rasa HQ GitHub. And we're also built on top of a lot of other open source libraries. So our main machine learning library is TensorFlow. We just upgraded to TensorFlow 2.6. So if anyone wants to talk about that, we got lots to say about that process. And of course, Spacey, which is a fabulous another library. And we are almost completely in Python. So if you were wondering about details there. Now, task-oriented dialogue systems. So chatbots are wide and varied, and there's a lot of things that you could call a chatbot. A task-oriented dialogue system is a specific type of chatbot. Task-oriented means somebody wants to do something. So we work with a lot of enterprise clients. So maybe you want to upgrade your insurance or check the account balance on your bank account or order a pizza, something like that. And in order to accomplish this task, you're going to use a dialogue system. So you're going to talk to a computer using a conversation. So sometimes you also hear people talk about conversational interfaces. So very broadly, that's what I mean by open source AI chatbots. We're not talking about open-ended chit-chat bots. This is a very specific use case and the one that most Rasa developers are developing bots for their jobs. And usually this is what they need. So how do they work? I'm going to start with a very brief history of natural language processing. So a little bit of background about me. My PhD is in linguistics, and I really focused in natural language processing, and particularly how we can use those methods to handle socially based language variation, things like accents and dialects and stuff like that. So this is something that I've done quite a bit of reading in. And way back in the 1950s and 80s, when the field was first coming online, all systems were basically rule-based, right? So someone would sit down, write a bunch of rules to describe the expected behavior, and then those rules would be used to generate language or understand language. A lot of the parsing literature started off here as well. So if you're familiar with ELIZA, probably one of the most famous chatbot systems, ELIZA was developed as a therapy chatbot. So you'd say something, ELIZA would parse it and using only rules, rephrase it as a question, and then you'd answer the question. So it was this sort of psychotherapy session, and very appealing. People got very excited about chatbots in the way back. And then it turned out that they were sort of limited in what they could do. And then starting in the 1990s, we see a lot more statistical methods. So instead of writing a bunch of rules, you'd start to count things. And then you would look at the counts of things and use that to determine the behavior of your system. And a lot of those methods were, again, taken from statistics. And then starting around the 2010s is when we really start to see neural methods, so deep learning methods. A lot of the early work was in embeddings, so creating a numeric representation of text for use in downstream tasks, and recurrent neural networks were the dominant architecture. And this is while I was in grad school. So when I was in grad school, sort of the hottest architecture was bidirectional LSTM with attention, which is a type of recurrent neural network. And then starting in 2017, we had a new wave of methods. These are called transformer methods. They're still neural. It's a different architecture family within the sort of broad, deep learning framework. And these got a lot of press, a lot of attention, and they're very useful for a number of language tasks. So if you've heard of BERT or GPT-3, the T in those systems stands for transformers. So this is a very brief history of the field of NLP. And of course, we do use transformers. They're very useful for open-ended systems. I'm going to talk about that a little bit more. But we also do use rules, and we recommend that developers who are using Rasa use rules in some situations as well. So when I said we use both types of methods, little a, little b coming together, and I would say broadly, you could describe all of these approaches as AI, depending on who you wanted to fight about phrasing. So rules versus neural methods. Again, we recommend using both of them, but in different ways. So neural methods, this is what a lot of people will call AI, although an AI system can be completely rule-based. Neural methods are very flexible. So they are good at handling things they haven't seen. They're probabilistic. They'll always make a guess. And if you need a guess, and hopefully a guess that's correct, they are fantastic. But the downside is they can also be unpredictable. So for example, there's been a lot of work recently and excitement around generating text. So things like GPT-3 code, what's it called? The code completion tool from Microsoft and GitHub that launched recently, all those sorts of generation tasks. We strongly recommend you don't serve generated text to users. It is impossible to make guarantees about it, such as they won't, say something that might be offensive or factually incorrect if you are using these neural methods. And another downside of them is that they require a lot of training data. So neural methods learn by example, and the more examples you have, the better they are. The more time you have to spend finding and labeling examples and curating that data and making sure that it is accurate and as complete as possible. And I think a great example of why it pays to be a little bit careful and cautious about when you, apply these methods is, so I use Tay from Microsoft as an example for a long time as a system that using generation without, lots of rules in place, generated toxic language. And then this one happened earlier this year, 2021. And another example where generated language based on some training data that was provided by users ended up being toxic. So you don't want your company in the headlines. You don't want your project to be this type of thing. So very useful in some places. Also, they are very English centric. So I know the conference is based in the US, but a lot of our users don't speak English, which is actually, well, or building systems that are not for English. And actually, most people in the world don't speak English. And English is a little bit of an outlier in terms of natural language processing because it has more data available and computerized than any other language by several orders of magnitude. So methods that work well for English are not necessarily going to work well for other languages. And we have an example here actually from somebody who was working on Rasa open source for Vietnamese. And what they found was that orange line at the bottom, that's just sort of a slope, is the transformer-based method. And the blue and the green lines up top are not transformer-based, they're using different methods. And as they added data, the transformer-based method got better and better, but this 700 examples was all the examples they had. So for a smaller data set, for a language that has less training data available for it, it can really help to not use, unfortunately, the very large methods. Okay, sorry, I thought I'd skip one. And, just another couple caveats about transformers. I'm not saying don't use them, but specifically transformer language models, these are things you should be aware of. They're very big. Actually, this chart is now incomplete. There have been other much bigger models released, I think most recently by Microsoft was the latest behemoth that was announced. They're big and they're expensive. They're expensive to train, they're expensive to store, and they're expensive to serve, and they can introduce latency. That may or may not be a problem for you with your particular application, but for lots of folks that I work with, it is. And just an FYI, you can actually get PII out of training data from transformer models. So this was a paper, again, from earlier this year, 2021, that showed this. And a lot of the approaches with transformer language models, you take the trained model and you do what's called fine tuning. So you have additional data and you let it see and train on that additional data, which would then be potentially, findable using these extraction attacks. So I'm not saying don't use them. I'm saying be cautious, really do your research, know the pros and cons. So those are the neural methods. Rule-based methods, they do have some cons. So they do have some pros. They do have some pros. So one, they are reliable. You know, you're always going to get a predictable behavior. If you're coming from a software engineering background, you're like, I can write a test for this, right? Very robust and predictable. They're easy to interpret. You know what's going to happen. You don't require training data, right? You just know the sort of thing you want to capture and then translate it into a rule. Very predictable. You're not going to have instances where your bot is saying things that you never told it to say. The flip side to that is, and the reason why not everyone is using rule-based systems is they're very narrowly defined. So every time you want to add a new behavior, you have to add or modify a new rule. And once you get to the point where you have a lot of rules, it becomes very, very difficult to understand, update, and maintain. So changing a rule here in the system might affect a rule here in the system. And it's just complex. It's just hard. And they don't adapt to unseen situations. So a neural method seeing unseen data will give a guess. It may not be a great guess. A rule-based system just won't. It'll fail. And of course, they're not the fancy talk of the town for sure. So where do we use neural methods and where do we use rule-based methods in Rasa? So there are sort of three big components to any chatbot system. How they're organized and the degree to which they sort of bleed into each other will depend based on the system. I'm not going to talk about response generation because we recommend you just write your responses, especially for a smaller assistant or chatbot. But the two main components are NLU, that stands for natural language understanding, and dialogue management. So natural language understanding is the general task of taking in human language data in some form and converting it into a computer readable form. So a lot of times when people talk about unstructured text with someone with a linguistics background makes me a little bit grumpy because all text has structure. All human generated text has structure. But what they mean is it's not computer readable, right? It's not like in a JSON with the important fields annotated and extracted. And then dialogue management is deciding what to do next in the conversation. So for the entity extraction and intent classification, these are both types of natural language understanding tasks. We actually have a research team at Rasa, and one of the things that we've worked on and included in Rasa open source, should you choose to use it, you can configure your pipeline however you want, is DIET. So this is dual intent and entity transformer. T stands for transformer. I told you we used them. So this is multitask learning. It does both of them. And it's really good to have a flexible system here because somebody can say, can express an intent. So this is something that a way of classifying turns in a conversation, depending on what the user wants to do. Someone can express an intent in, basically infinite different ways, right? If I'm asking to borrow a pencil, I can say, hey, you've got a pencil, or I could rummage in my bag and be like, looks like I don't have a pencil. Or I could say, do you have anything to write with, right? I don't even necessarily have to say the word pencil, but I know you've got a pencil because I can see it on the table. So all of those sorts of varieties make it really, really hard to capture in a rule-based way, the way that all the ways that somebody can say something. Using transformers here is very helpful. Same with entities. So particularly things like named entities. So someone's like, hey, my name is there's a lot of human names. You're not going to get a database with all possible human names in it. And even if you do have all human names, it may be usernames, right, that are not in that database. So having a way to do this in a very flexible manner makes a lot of sense. Also, I will say, just as an aside, anyone who's already using Rasa, if you upgrade to 2.6, I would recommend not using the entity classifier. There is something about the TensorFlow 2.6 upgrade downgraded the performance specifically of entity classification in DIET. We think it's something to do with the CRF layer. If you are not using this, ignore that. That's just something that we are currently working on. So we do both. The CRF layer is this blue one here. It's the one making problems for folks right now. So we do both, and also we encourage the use of pre-trained embeddings, which also can be trained using transformers or neural methods. So a very flexible way of understanding, in a computational sense, understanding the text that's being input. No, go back. There we go. Sorry, I hit the button too many times. So that's where we're using the machine learning components in the natural language understanding. What about in the dialogue management, deciding what to do next? So Natural language understanding, we're doing intent classification. That's a turn level multi-class classification problem. We're doing entity extraction, so looking over a string of text, identify the set of characters that is an entity and what entity it is. Dialogue management is the task of, given the history of a conversation, what should you do next? So we use machine learning policies for this as well. So we have a Keras policy that I think is going to be deprecated in our next major update, but if you're a Keras person, this is a great place to go in and maybe do some experimentation if that's something you're interested in. And this just uses an LSTM. That's a type of RNN. That's the architecture that was really popular before transformers. And guess what? Still works to predict what the next turn should be. And also TED, which is a transformer-driven policy. That's another one that we've developed in-house to figure out what the next turn should be. So we do have transformer and other neural network methods in here to do guessing, but the rule-based policies are really sort of the meat of most conversations where you're deciding what to do next. So the clearest rule-based one is the rule policy, which I'm showing just a little example of here. And basically, this is a simple if-then, right? Like you put in any programming experience, any programming project, right? Same general idea, except it's with conversational turns. So if the user says greet, by golly, I'm going to greet them back every single time. So this is one way that we have rules incorporated. And you can imagine, especially for commercial assistant, a lot of ways where this is very necessary to have. So for example, if I have a shopping assistant and I ask you, hey, are you of legal drinking age? And you say, no, I'm not going to sell you alcohol, right? So having guarantees of behavior is very important. And I think you can all come up with some other examples where that might be the case. And I think I have accidentally deleted a slide while I was preparing. But the other place that we use more of a rule-based system is in order to decide what to do next in the conversation. So the training data for these policies, which are machine learning policies, is sample conversations. So the user says, hi, I say hi. The user says, hey, I need to check my balance. I say, great, let me get your user account information. You get the account information, you validate the account information, you say, here's the balance. That sort of flow, and presenting that as examples. And if the conversation follows a flow that you have an example of, it will just continue to follow that flow. So this is what we call a memoization policy. I don't want to get too in the weeds unless somebody has any particular questions, but basically it's looking at the examples, and if it's seeing something that looks exactly like an example, it just sticks with it. So, and I would say for most deployments, for most chatbots, 90% plus of conversations are going to be turns in a conversation are going to be governed either by the rule policy or the memoization policy, and the machine learning policies will come in when there's sort of an edge case and the system's not entirely sure what to do, using a more predictable method. So that is a very high level view of how Rasa works, where we are using rules, where we are using more machine learning approaches. I don't think I mentioned it, but another place where we use rules a lot for entity extraction is regular expressions. For example, for addresses or things like that, we really like the Duckling library, which is another open source library for entity extraction. And Duckling is a bunch of regular expressions that somebody else maintains that, hey, I know what addresses look like, I'm gonna extract addresses. And you can usually get really pretty substantial performance improvements by using regular expressions instead of machine learning methods for things that you know the structure of. Very high level. If you have any questions, please feel free to ask, and I'll do my best. So I think if you've worked in chatbots previously, it may be clear to you at this point that things are a little bit different than you might be familiar with. So most chatbot systems previously, before, I guess, the machine learning revolution, I guess you can call it, were built by sitting down, writing a bunch of rules, building out a dialogue tree like you get in a video game dialogue for like an RPG or something, and using that to guide the conversation. And if somebody didn't follow the flow, well, but that was the work, right? It was predicting the conversation flows and writing them all down. That's not really the work so much with a more machine learning approach. So the general approach that we recommend is something we call conversation-driven development, like test-driven development, except it's conversation. or CDD, which is how I'm going to refer to it from here on out. And the idea is that you spend very little time prototyping. So you get the single most bare bones system that you can, and then as soon as possible, get it in front of people to use. I'm not saying immediately launch to users. I'm saying start with test users as soon as possible. It is so hard to predict what people will say. It is so hard to predict what people will want to say. Even if you have, the best UXR in the world, you're still going to be surprised by the ways that people phrase things, by the things that I think the bot will be able to do. So being able to really see how people are interacting with your assistant as soon as possible and making sure that you are meeting their needs is really the only way to build something that works. Yeah, there's going to be a lot of annotation discussion in the next little bit. So sharing, I mentioned just like literally as soon as possible, especially for a simple assistant. I wouldn't spend more than a week of development time getting your prototype up and immediately, like even just sharing it within your team. I can't count the number of times where I have sat down, I've started working on an assistant, I have like my conversation flows. I'm like, okay, I've got my training data, I'm feeling pretty good about this, I'm gonna get it in front of test users, and they've just done things I did not expect every single time. So as soon as possible, which again is very different from the state machine rule-based approach where you don't share with users until the system's basically done, and the system is very difficult to change at that point. So sharing, getting people to use it. Okay, you've been surprised. What now? So the next thing is to look at what people are saying. And this could be you as a developer. It could be, you might have a team that's doing annotations. Some people outsource this to just more for the design, and before launch, I would definitely do this within your development team. But after, I know a lot of folks who do outsource it, a lot of teams that do outsource it. Read what the users are saying. Look at how the conversations are going. Don't worry about specific metrics. There's a lot of ways of evaluating conversations. There's a lot of frameworks. All of them, every metric that you're going to see for evaluating a conversation is going to be lossy. It's going to lose a lot of important information that you as a human being who know how conversations should work, and particularly know how you want the conversations of your assistant to work, are going to be able to pick up on right away. So just look at the conversations, open mind, read through them, spend some time looking at them. If you're familiar with something like content analysis, this can be a great time to do a content analysis, see if there's any like specific conversation flows that you are missing. And also, just as an aside, make sure that this is covered in your privacy policy before launch. So this is a great example of a place where looking at a conversation will tell you what is wrong and help you to fix it, right? So this is just a tweet. Every so often I look up people who hate chatbots and I take note of it, and I'm like, we can fix this, we can do better. So Owen here from Twitter is saying, I hate chatbots so badly. My last 10 minutes, FedEx chatbot, 1 p.m. or 1 a.m.? Me, 1 p.m. Chatbot, did you say 1 a.m.? Me, 1 p.m. Chatbot, did you say 1 a.m.? Me, 1 p.m. Chatbot, I'm not going to read the whole thing. But basically it's a repetitive turn. And what Owen wants to happen here is he is providing the correction. He wants the correction to be acknowledged and the update to be made. Instead, what's happening is, first of all, that there is an error in entity extraction, right? So 1 p.m. is being misidentified as 1 a.m. And the second thing that's happening is I think the chatbot is expecting him to say yes or no, rather than replying with the correction, which I absolutely see developing a conversation in isolation. Definitely understand how you could get there, but he is not replying yes or no. He is replying with a correction. This would be extremely flexible if you knew it was going to happen. And if you knew it was going to happen because you'd seen people try to do it previously, right? So reviewing a conversation would make this very, very fixable. But you have to review, right? You have to look at it and see that this is what's happening. And if you're looking at something like number of turns spent speaking to the chatbot, oh, it's great. If you're looking at something like how quickly is the person responding to the chatbot, oh, it's great. So depending on what metric you're looking at, your metrics may never pick up that this is an issue. So annotating, you've got the data from people who are using your chatbot. What do you do now? Well, you annotate, you add labels, and you add it to your chatbot. And this is what's going to be, at this point of the development process, the bulk of the work is data annotation. And I I know that that is not very satisfying if you're like AI chatbots. I want to spend a bunch of time like building models, but it's just that's the work. Just what you got to do. There's not really any way to get around it. And a question I get quite a bit is, hey, can I generate synthetic training data instead of annotated real user training data? I would strongly recommend against this. So particularly reinforcement learning, there was a bit in 2017 where people were really interested in trying to build chatbots using reinforcement learning. It's just a type of machine learning, if you're not super familiar with it, where a system gets rewarded for doing some sort of behavior and it tries to figure out how to do that behavior more. So AlphaGo is a good example of a reinforcement learning system if you're familiar with it. And as it turns out, if you are doing a task-oriented approach to building chatbots, and your goal is to have the system do the task without extremely carefully constraining the linguistic output, you end up with what's called degenerate output, right? Stuff that does not look like human language. And there was a bunch of like fancy news articles where they're like, these bots invented their own language. And really there was just no constraint that the language looked like a good, well-produced human language. I'll tell you right now, it is going to take you more time and effort to try and write constraints to have a reinforcement learning system produce good human language than it is just to get user data. And user data is going to be from your population of interest, right? It's what you want your system to handle in production. So don't do that. You'll set yourself up for heartbreak. I would strongly recommend against it. Instead, use the data that you have and annotate that, and fold that in, retrain, retest, and deploy. And this is just an example of what annotation can look like. And if you're wondering about these sort of GUI screenshots, these are from a software offering that we have called Rasa X. It is not open source, but it is free to use. And then there's an enterprise edition if you're an enterprise, and that's how we make money. If you're wondering how the company stays solvent, that's why. And this is a tool to make it easier to annotate data, add training data, test, deploy, et cetera, within a GUI framework that can be really helpful, especially for cross-functional teams. So that's what those are. And then testing. You got to test. I think this is an audience that this will not be a surprise to. You can't ship without testing. And the way that we recommend testing is using whole conversations, right? So I mentioned that the training data you provide to the system is these patterns of conversations, and you use those same patterns of conversations, but you add the user turn and what you expect the output of that, the intent classification and the entity extraction to be. And then, we have a command line interface. It's just raza test is the command to run the tests. And we also do a bunch of sort of machine learning output to help you get a better understanding of like if you've got a class imbalance or something. I did a live stream about this on Friday on the Rasa channel if you're interested in more information. So automating your tests, making sure that everything looks good. I'm not going to harp on it. Y'all know what tests are. And I think this is a great example of a conversation where testing would have helped. So someone is talking to a chatbot. They're trying to complete some task. The task that they want is billings and payment, which here is being represented as a B parenthesis. And that B parenthesis is being rendered as the sunglasses emoji, both in the text that the chatbot is sending and also the text that the user is entering to be sent to the chatbot. I think that this probably wouldn't actually be caught in the assistant. I think this is probably an integration test. This looks platform specific to me, whether or not that text input is being rendered as an emoji. This is a horrible user experience. I think this person is perfectly right to hate chatbots in this situation. They can't do what they need to do. They're following the directions exactly. It's not working. So just a little sprinkle. Absolutely do your unit tests. Make sure you do your integration tests as all your channels as well. And then finally, tracking. So how do you know which conversations are successful and which conversations have failed? A big part of that is looking at your data, annotating and reviewing, but also there's probably a reason you built the system, and there's probably a specific metric that whoever told you to build the system cares about, right? So it might be click-through rate, it might be conversion, it might be other KPIs, it might be time spent with the assistants, or people getting in and out really quickly and fixing their problems. Are users not getting back in touch with support after using the chatbot? One that I really like is, are people choosing to use the chatbot, right? Are they opting into using the chatbot specifically on their second or third interaction? And I've seen, I really want to share something. I don't think I can. And I've seen some really impressive statistics about people choosing to use the chatbot because it is faster, when the system is well designed, when it's meeting their needs. And that's great. That's great signal. And then fixing. So you're going through, you're looking at conversations, maybe a text has failed, you need to fix the test. Maybe you're finding a class imbalance, you need to fix the class imbalance. Maybe you're finding a lot of people suddenly have a new intent that you don't have in your training data that you need to add. So a great example relevant for this year would be maybe something about safety procedures or sort of general disease-related questions in a bot that previously had not seen any of those questions. So being able to handle new types of conversations, adding new conversational flows, the user conversations, particularly if it's something your system can't really handle, you can go through and fix and just add to your training data so your system can handle it in the future. Yeah, and just continuing to iterate and build and improve your system. So this is a final example of somebody who hates chatbots. This is somebody who wants to talk to an assistant, and when they have a conversation, sorry, it's somebody who wants to talk to a human being. When they have a conversational turn, they learn that it is in fact an assistant. I think this is a great thing to fix, right? This person is having a bad experience, maybe replacing the picture of a person with a picture of like a cartoon chatbot, or maybe changing it so it's not a person's name, so it's clearer the type of experience you can expect to have. So just, seeing what the problems are and making them better. Isn't that engineering? And you're probably thinking at this point, wow, that's a lot of work. That's a lot of work of annotation. That's a lot of work of like iterative improvements of the system, of redeploying, of retraining. And it is, and we definitely understand that this is a huge time commitment. But if you are putting in the time to build a conversational interface, presumably you want it to work. And if you want it to work, it takes a lot of work, right? You wouldn't, I was going to say something. I actually don't know that that's true. I was going to say you wouldn't just sort of like draw some squares and call it a GUI and call it a day. Maybe you would if it was for like a hobby project. But conversations are judged by human conversations because that's where we learned about how they work. And that's always going to be the thing that people compare them to. And if we can't have a successful conversation, if people can't do what they need to do, accomplish their task in this task-oriented dialogue system, using the dialogue system, then like, why'd you build it? Why are you maintaining it? Why is this a good use of your time? And I think that I don't know, certainly I, and perhaps you also, have experienced a lot of chatbots that just don't work and are very frustrating and that people hate using. So especially in 2016, when they were first becoming like a thing that people were excited about, there were a lot of sort of not very useful, not very helpful, not very well-built systems put out there, and a lot of ill will was generated as a result. So yeah, we know more about how to build good chatbots now, and I would encourage you to consider the scope of the project before you start. So I want to make sure that I leave lots of time for questions. I talked a little bit about what I mean by open source AI chatbots. What I mean are task-oriented dialogue systems built using open source tooling. You don't have to open source the chatbot you build unless you want to. We have no expectation that you will. Built using open source tooling that incorporate both machine learning and also rule-based approaches to build robust systems that hopefully do what you need them to do. How do they work? We have multiple components, the NLU component that extracts information, computer readable information from user-generated text, and then the dialogue component that decides what to do next in the course of a conversation. And what does the development process look like? Conversation-driven development, to put it broadly, and it's a lot of looking at data, annotating, updating your model, running your test, fixing what's broken, getting it in front of people, seeing what people do, and really continuing to work through this iterative process of development where you are using user conversations to make sure that future user conversations either continue to go well or go even better. So I will open it up for questions. If you've got any questions for me, my Twitter is @RCTATMAN. I'm very available on Twitter. Our GitHub is Raza HQ, and if you're interested in seeing the source code for the framework, that's /Rasa. And then we also have forums. So if you have questions, of course, we're always happy to get GitHub issues or pull requests if you're interested in contributing. But if you just have sort of like general questions, our forums are generally the best place to go for that.